Hi class, let's take a look at example 2. In example 2, once the same as the previous problem, they want us to technically provide a sketch and eliminate the parameter. Now, not on all the actual problems you're going to be able to eliminate the parameter, and the main idea with the review is just to basically provide these sketches, since we're going to be calculating areas and then doing rates of change within the parametric equations. Okay, so what I'm going to do is I'm going to look at the domain of t, and t is greater than or equal to 0. So I'm going to start with technically t is equal to 0. And let me make my table. X is equal to 3t plus 2. And then our y is equal to 2t plus 3. And then technically we're looking at just x's and y's. And a total of 3 coordinate points is sufficient. We can use negatives because technically t started at 0. And I'm referring to t, not the x's and the y's. So the minimum is going to be at 0. So x is equal to technically 3 times 0 plus 2, which is equal to 2. And then your y value is 2 times 0 plus 3. So y is equal to 3. Coordinate point, it's going to be 2, 3. So this is going to be our first coordinate point. So we said it was 1, 2, 1, 2, and 3. At this point, t is equal to 0. And let's technically look at the second one. And I'm just going to use 1. So x is equal to 3 times 1 plus 2. X is equal to 5. Y is equal to 2 times 1 plus 3. So y is equal to 5. So technically, so that would be 2. Yep. So you're going to get 5, 5. So in this case, this is 2, 3, 4, 5. 3, 4, 5, not to scale, but it's there. This one's going to be linear since there's no technically exponents on the t's or anything like that. And then let me go to the next one, which is just going to be 2. So x is equal to 3 times 2 plus 2. So x is equal to 6 plus 2, or x is equal to 8. Your y value, it's going to be 2 times 2 plus 3. So y is equal to 4 plus 3. Y is equal to 7. So 8, 7. And let me double check. This is supposed to be a t. So that would be 8, 7. So we're looking at 1, 2, 3, 4, 5, 6, 7, 8, 5, 6, 7. So that's going to be about here. This is t is equal to 1 and t is equal to 2. Now let me actually write it in this format, and notice that your actual function is increasing towards the positive infinity on the axis. So that would be your parametric equation. This one's actually linear. Notice that I'm putting all the arrows going in a specific direction. That's because it's based on the values of t. Okay, so there's a sketch. The second portion is they want us to express as rectangular by eliminating the parameter. So let me actually do it on the second page. So we have that x is equal to 3t plus 2. And then your y value was 2t plus 3. So this is 2t plus 3. Okay, so what I'm going to do is I'm just going to pick one equation and solve it for t and then plug it in into the other one. So we're going to be subtracting 2. Therefore, we're going to have x minus 2 is equal to 3t. And then divide by the 3, divide by the 3. So that our equation in terms of the t's happens to be x minus 2 divided by 3. Okay, at this point, you can plug it in into the t function in order to express it as a single y. So y is equal, a single x's and y's. So y is equal to y is equal to 2 times x minus 2 divided by 3 plus the values of 3. Or y is equal to, this will be 2x over 3 minus 4 over 3 plus 3. And then at this point, let me get an LCD of 3. So times 3 and times 3. So our actual y value happens to be 2x over 3 minus 4/3 plus 9/3. So y is equal to 2x over 3 plus 5/3. Okay, the last portion is to actually, fix the actual domain of the x's. So technically, your problem, it's only good for, technically t is greater than or equal to 0. At t is greater than or equal to 0, that happens to be the domain. So technically, this is only true for x's greater than or equal to, the minimum was 2. So that would be our complete answer. So in this case, x is greater than or equal to 2. That would be the proper, technically function. And this is because your t is not allowed to be negatives. So in this particular scenario, we will be looking at t is equal to 0 as the minimum value and nothing below that point. So that would be your x's, and that would be it.